Hello and welcome to another XNA tutorial on how to make a game in XNA. And in this tutorial we're going to increase the performance by messing with the pathfinding algorithm for our enemies pathfinding and changing the way we're handling our threads. So let's see, the first thing I did was I went to this write map method. I know you just copied this from my file that I uploaded, so you guys probably aren't very comfortable with this class that I'm showing you right here because you guys didn't write this. But basically what I did is I added a new argument for write map right here, which is the argument is offset. And if we go back to our enemy and let's see, we go to our find path method, we see I put in the position as the offset. So basically what I'm trying to do here in the write map is basically narrow down the map or the area in which the pathfinding algorithm has to search. So for example, right now if we have a large map, it's going to search through the whole map trying to find a path to the player. And more than likely it's not going to be the map isn't going to be a maze, so the enemy won't have to look through the whole map. And so what I'm doing is basically just making a smaller box out of the original map by putting in the enemy's position or offset, and here, and I'm minusing it by the screen width and height, half of it. So basically the area in which it searches is within the screen, the screen's dimensions. And yeah, so that's basically what I did here. You can take a quick look, go into full screen 1080p and just copy all this. Should be pretty self-explanatory. Excuse me. Let's see, what else did I do? Oh, that's mainly what I changed for the write map for the pathfinding algorithm. Now I mostly changed the enemy, and I did one thing in the game. So in the game 1 class, I put this using system.threading right here because we're going to use threading in the game class, and I just made a public static variable called t, and I made it a thread array. Has 3 slots basically. Has a size of 3, so 3 threads total. And if we go back to our enemy here, it changed quite a bit of things. Okay, I got rid of this whole section if statement here, and I just put the method set path right here. So every step is going to set path. And in the update method, I put this if statement here saying if point distance, if the distance between the man and the enemy is smaller than screen.width divided by 2, which basically is the longest, half of the longest, or basically the radius of the screen. So if it's smaller than the radius of the screen, which basically means if the enemy is not in the screen, it won't even check for a path, so it won't even try to find the player. Since this is going to be a sort of like a Nazi zombie game, we might change this in the future, but this is just the way I have it for now. Might tweak that a little bit. Here. Okay, biggest thing was set path. As you know, set path, it just, basically set the path. And we had to put it in the if statement, but since we're doing it every frame, we had to make a couple changes. First change is this set chain of if statements, basically saying if the thread that we're using globally to find a path, if that does not equal null, basically if it's active and it's alive, basically meaning if it's currently searching for a new path and using that thread, it's just going to return. It's going to block it. So that prevents us from interrupting this and starting a new thread again. So this basically says if the thread is working, don't do anything. Next thing is the destination. this was actually in the original if statement here, so I just moved it right here. We don't actually need this path index equals 0 because we do that once the thread is done. So destination equals man.man.position. That basically sets where you want to search. So obviously we want to search for the man's position. Next thing is I re-added the pathfinding queue. So you see these ones right here, pathfinding.q++ and pathfinding.q-, in both these if statements. So just so we don't have all the enemies at once creating new threads, that would be bad. So right now I'm just having one guy on one thread at once, and pretty much everything else is the same. You know, instead of using the t variable for the enemy, I'm just using the global t variable, and so it's a little bit easier to keep track of. So not every enemy is creating like a new thread. So we know we have a controlled amount of threads, so our game doesn't slow down. And that's pretty much the changes. And the reason this is going to work is because it makes it faster. Is because when the enemies search for the new path, they completely stop. Once they completely stop, they start searching for a new path. And it doesn't look good if we start adding the queue and different enemies are waiting for each other to find a path. You're gonna have a bunch of zombies just sitting there doing nothing. And if you move, they're gonna be following an old path. So that's not desirable. It just doesn't look good. And if we get rid of the queue and all the enemies start making new threads all the time, our game is going to get extremely laggy. So this is a nice medium where it keeps checking constantly for a new path, but it does it while it's still moving. So it keeps checking for new paths even while it's moving, so it simulates that it's running quicker. So as you can see, this is our spawner. You know, everything's working properly. First zombie here. Let's just actually let a couple zombies spawn, just so we see that it's not laggy. And if I had fraps here, we could have our frames per second, but I'm not doing that. So as you can see, we have 5 zombies now, all following. If this would have been a laggy mess. Here, actually, let me see if I go out of bounds. See, the zombies stop following me, and that's because they're out of my screen area. But you see, once I come back, see, they're gonna all start becoming active again. And whoa, okay. So I mean, we still have a little bit of work to do. The zombies still stop, but that's because they reached the end of their destination. So see, if we go sort of far away where all the zombies are, I mean, we have enough zombies coming at us at once to keep us busy. So it's better than the last, and it's non-laggy. So that's pretty good. You know, in the future, I'll probably tweak it a little bit more to make it perform better and more fun to play with. But right now, this is the best situation I could find. So yeah, we're done with performance, and now we can go on to do some more fun things. Okay, so probably the next thing I would like to get started with is a map maker. And what a map maker is basically just a map editor. I just call it map maker. And this will be almost a completely another game, but it's still going to be in the same project. And it basically allows us to click on the map and add new blocks and things like that. And and then when we save it, it's going to export it into an XML file, and then our game, when we run it, can read that XML file. So it just makes it a little bit easier for the developer to make maps. So yeah, so since we made this nice fancy XML reading system, we might as well make a map maker for it. So that'll probably be in a future tutorial though. So thank you for watching. Please give it a thumbs up, favorite, comment, and I'll see you in the next tutorial. Thank you. Bye.